Hello everybody and welcome back. About a week ago, a few videos popped up on YouTube by Ivan Miranda and Tom Stanton, and they were showing a contraption that would make it possible to project images into long exposure photos, and it was really cool. I've got both of these videos linked down in the description, and I would ask of you to please go and have a look at them. If you're not subscribed to their channels, please subscribe, please like, because this is truly amazing, and I will be coming back to this after you've watched them, because I really love it, and I'm going to try and do something very similar on a slightly different basis. So now that you're up to speed on what this is supposed to be all about, I do have most of the parts that they were using, but most of the parts are sort of different, so we'll need to do things differently. First of all, I have loads of these so-called crappy pixels. They're called crappy because they're not the original WS2812, but a counterfeit chip, which is notorious for flickering and not having a very good balance of light. You can turn them off, but if you turn them on, they're like at 25% of intensity. So I have a whole stash of these things, I think about 20 meters, and I've been doing projects to get rid of them, and this is going to be one of them. So we have loads of these, and I'm only using these for demonstration purposes. And we've got a microcontroller. I don't have a 32-bit teensy, but only a Arduino Nano, which is kind of constrained in performance and memory and everything. I do have a SD card reader from 3D printer that already has this nice cables attached to it. I have, what do I have? I've got power supply modules that we can use to put these together, and yeah, I think that is about all that we need. I also went ahead and I got me a piece of wood, and now I have quite a lot of these NeoPixels attached to a piece of wood, and I've built a simulator for this, and it appears to be working. It still needs some touches, but it's pretty simple. Now, the first issue that we have is the Arduino. The Arduino itself is pretty small. It runs at 16 megahertz, and it has about 1.5 kilobytes of memory. That is kind of an issue because I have 252 LEDs on my strip, and 252 LEDs require 756 bytes of memory to store their RGB data. That would be more than half than we have here. So that didn't really work out. So I thought I would take these 252 LEDs and split them up into several rows of LED strips and have these LEDs be slightly offset, so when you move them they will form one line again, because of the persistence of vision in the long exposure. That gives us 3 times 84 LEDs. Sorry. For which we then need 252 bytes. Man, I can't write today. And 252 bytes of memory, that is feasible. We can get this into an Arduino. So this makes the software slightly complicated, but we can actually put this software into the generation phase, because we start out with an image and we take this image and we turn it into rows for all the LED stripes, which in turn becomes the data that we store on a file. So what we do now is we actually turn each line into 3 segments. Number 1 goes into the first row, number 2 goes into the second row, number 3 goes into the first row. So we end up with several rows of LEDs that all have their data. And we do this in the generation phase, so once we have this file, it will have all the data already in the right format, like row 1, row 2, row 3, and then we'll get to the second row of the original picture. And because we can now read each row in turn inside of the file, because inside the file we'll have the file start at 0, and it will be going on, and there will be row 1, row 2, row 3, and each of these will be 252 bytes. So we don't need to do anything, we can just always read 252 bytes and display them onto the LEDs and then move on. We never need more than 252 bytes buffer. There is one drawback to this. The usual libraries for driving these LEDs would like to have all the LEDs in series, and this gives us one big problem, because if we have this Arduino here with the USB, a little chip on it, and with a connector set for programming, and we have all these connectors here, we now need those 3 strips of LEDs driven with 1 line each. Usually it would be one big array, but we've got 3 of them. We have one here with all the little LEDs on it. We've got another one here, and the third one over here. And each of these get 1 data line. So we don't need that much memory. And since all of these LED stripes store the data as long as they're not written, we're fine with that. So we just reduce the amount of memory needed to 1/3. The other thing that we have is we've got the SD card module, which uses SPI. And that would be it. I thought I would also add another stripe for diagnostics with just 4 LEDs. Let's see if that works out. And I want to have 3 switches. So I can select which picture I can display, and all of these will be grounded. and we've got that too. The only thing that we need now is a power supply for the strips. That gives us our 5 volts because they need 5 volts, and they do need quite a lot of power, so we'll use 2 power modules with one big LiPo attached to each of them. Now, that is the hardware. The software is going to be the SD library on the Arduino. I will be using the Light WS2312 library because it is a lot smaller than Fast LED, and I can very easily reconfigure the pin for the outputs as the software is running. And everything else is just going to be homebrew. So, yeah, let's get towards making it. So this is the complete circuit for the SD card, and here are the sockets for the LED strips. The ground pin is part of this connector, but I just realized that I have one little flaw in the way I thought this out, and that flaw is that I should probably connect the Arduino to the primary side of the battery so it can use its own power converter, its own linear converter, so I don't get any of the noise that's on the LEDs, because these micro SD cards are very much dependent on a constant power supply. So I should probably look into that. Yeah. So it'll need another set of wires to the Arduino that will go to the primary side of the battery, so it can use the voltage dropper here. Yep. Need to do that. So this is now our power connection to the Arduino, and that is going to the voltage in on the Arduino. That's better. Yeah. So this is the electronics already on the back of the board, and LEDs are up in front here. There are interconnects between +5 volts and ground. I'm actually leeching the power for the small LED panel on the back, and there's one connector for all of the data lines for each and every one of the LED strips. I'm gonna glue this down with some hot glue, and I will also glue down the power supply, and then we can take one of these batteries and see if it fires up. Yeah. So everything's connected up and glued into place. So we've got the LED strips. We have data lines to strip 1, 2, and 3. We have a fourth data line to the short strip up here. And this is not working yet, but I thought I'd add it anyway. We have the Arduino with the connector to each and every strip. We've got the SD card connector with SPI, and we have one of the small power supplies, and right in the end we've got the 3 switches, one which will be start, and the other one will be to select which file it's going to try and play. And yeah, so let's try and turn it on. There's already a sketch on there that will play a file from the SD card, and let's see what happens, if anything happens at all. It should be running with just one power supply for a start, because I've actually toned this down quite a lot because they're really bright. So let's not get this backwards, and here we go. So yeah, there's something happening. There's actually more happening back here. So this looks kind of promising, and it's also pretty quick. It's already finished. So this test picture is 252 pixels by 1000, or 1000 by 252. So quite large. The speed is good. The intensity is good too. Now I have to make some straps for the battery, and once I've got those, yeah, we're good to go and try this out. And I need to add the second power supply as well. I also added these Velcro straps to the back so it holds the battery. It seems a lot better that way because yeah, I didn't know how to fix them down better, but this looks really good. It's now quite heavy. I would think that it's about, well, about 1.5 to 2 kilograms. You can hold it really well. I'm gonna go clear up the software issues, and then we can put it for a test. So this is the finished thing. I got the menus working, so it's a very simple menu. You can just select one of 4 files that it will play. I could have gone for a lot more, but I thought that was simple enough. I've tried it out, it works pretty well. Once you've selected a file, you can press the start button. which will start playing the animation on the LEDs. I didn't do a lot of work in getting the pixels aligned, so the pixels going from left to right are associated to other pixels in the source picture, but it looks kind of cool, but it gives it sort of jaggy edges, but it generates a very good image with jaggy edges, and maybe I'll work on that. The other thing that I did was once the animation has finished playing, it will go into a 15-second pause before allowing you to press another button, so that you don't press anything accidentally while you're still doing the long exposure shot. Yeah, it worked really nice. I was going to go outside and do a few photos, but actually it started raining like 5 minutes before I was done with the project, which kind of figures. But it looks really, really nice. If you start one of these, it will play the animation, and when it's done playing the animation, it shuts off, turns all the LEDs off, and 15 seconds later you can restart the image. So once again, I'd like to stress that this was not my idea. This is Ivan Miranda's and Tom Stanton's project. I just wanted to do it using an Arduino, so all the kudos go to them. I just wanted to really quickly do this, get this out, make it open source, because I'm using open source libraries for this anyway, and I modified one, so I am obligated to share what I changed, and that's a good thing. So thank you very much for watching, and bye bye.